Hello, Dr. Gopakumar. Welcome to the podcast. Thank you so much for joining.
My pleasure.
So, before we could talk about anything else, could you take a couple of minutes and talking about what your research actually is?
So my research is in the broad area of string theory, and people often have a picture of string theory as something a little esoteric and removed. But one of my motivations to understand string theory was to understand it as a framework that would help us to even shed a new light on some of the interactions that we already have some understanding of. So not just gravity. So one of the main successes of string theory is that it provides a very consistent theory of quantum gravity. But I think what is less appreciated is that a string is a very broader framework to understand physical systems. There are string-like excitations even in condensed matter physics, in particle physics, in the strong interactions, in the study of the nuclear force, QCD as it's called, and there is a string picture underlying it which has not been understood and which I think would shed a completely different light on string theory as well as the strong interactions. And I think it's quite fascinating that, and on the one hand, it can describe quantum gravity, and on the other, something very concrete like the strong interactions. So my research has been actually focused a lot on understanding this connection between so-called gauge theories and string theories, and try to derive these from first principles and show how strings appear very naturally in nature. I think naturally as a framework for describing nature. I think a lot of the discussion on string theory makes it seem as if it's very far removed. It's some kind of theoretical fantasy. But I want to kind of show that it is really rooted in things that we understand well and how it naturally emerges from those systems. So that's the broad statement of my research program, which actually has been for several decades. And it has been understanding parts of this relationship through simple examples, through more developing multiple viewpoints on this question. It has been a long journey, and there's still a while to go. So that's what keeps me enthused about my research.
It's amazing, Dr. Rajesh. A lot of people know you that you got the All India rank one in the IIT JEE examination, but a very little less speculation has been on the fact that you did not take any coaching. In fact, that came up in one of your last podcasts that you gave with the Rocket Media channel, like where you clearly mentioned that you did not, go for any specific coaching. So, could you share what approach you took for, doing that kind of an achievement without any coaching?
Yeah, I mean, I don't know, people find it maybe a little. For me, yeah, the IIT, it was some exam I wrote many, many years ago, 37 years ago. But somehow having that has always, I think, fascinated a lot of people. But I mean, I am, as I say, a bit of an accidental IITian. I never really was planning to go to an IIT. I was planning to study physics all along, and so I think sometime after my class 10, I had a certain agenda of studying physics and mathematics. At that time, it was before the internet era and everything, and there were a few books that I could get hold of, which I liked very much, like the Feynman Lectures on Physics, another book on physics by Gamow and Cleveland, some books on mathematics. And I thought I will just systematically study them on my own because I didn't see any other way in which to study them. I didn't like the school textbooks very much. And I wasn't really planning to go for the IIT, but my friends around me and they took some of these. At that time, I think it wasn't Fitji or Allen. It was, I think, Agarwal classes and brilliant tutorials. They had like 2 year long programs. I think some of them, maybe Brilliant, had even longer. But many of my friends took these 2 year long things where I think they used to send you material and used to do the problems
Oh.
and go. I don't, I think maybe the in-class things were also maybe there, but I don't know about it. But many of my friends were taking these postal courses and where you solved and send it back, they graded it. And anyway, it never appealed to me. And I had a somehow a little bit of, I shrank away from all these things that instinctively it didn't appeal to me because I just wanted to study it on my own. I think I had a idea of what I had to do. So I studied physics, I studied maths. My school was allowed me to do, I mean, I used to often sit at home and just study. I wouldn't go to school. And my school was somewhat flexible, and my parents were also accommodating. So I continued with that. And then at some point, I wanted to give the JEE because I heard about in my class 11, I think I heard about after when I was going to class 12, I think I heard about the IIT Kanpur physics program, and I decided to this thing. So that's when I thought, okay, I should give the JEE, but I still didn't want to take any coaching classes. But there was some book of problems that the brilliant tutorials had, which my parents at least said, why don't you at least take that? And I didn't study much chemistry, so I prepared. So that was a book of questions. So if you wish, that was the only kind of something they used to call YG file at that time. I remember it had a lot of involved questions. I mostly focused on some of the chemistry ones, maybe 6 months before the exam, and but luckily you didn't have to give them any things. You didn't have to send any things to them for correction or anything. You could just do the question. So yeah, I did that, and I mean, yeah, I'm not sure what is the lesson. I mean, it's just. I think if you have a clear idea of what you want to do and you have a good set of resources, I think you can study on your own. It's the best way, I think, to learn a subject. You develop a certain self-confidence and independence of thought.
But I think the approach you followed, based on what you said, you would still advocate that it should work even in the 2026 JE as well.
I wouldn't advocate. I mean, I think what works for one person at one time may not work for others at other times. I haven't really looked at it. My son is in high school, and so he shows me sometimes some of the new IIT questions, and they seem to be now all multiple choice. It was not like that during my time. There used to be, I think, 40% was multiple choice or 60%. I don't remember. There was a 40-60 breakup, and the rest, there were multiple, but there were also subjective style questions where you had to kind of write out a proof or work out something. So I think nowadays these exams don't give you the chance to do that. And I don't know, just solving multiple choice things, I'm not sure what it really even tests. So I'm not a great fan of the IIT JEE exam, as you can make out. I'm not sure whether it really tests for very abilities for science or anything like that. Uh,
Uh,
so
Yeah. The next question actually is one of my personal questions that I've been having for a very long time. I tried Googling it, ChatGPTing, and doing whatever I could. I read one of your blog posts about why does a theorist love a blackboard very much. I have been, ever since I've been trying to ask a lot of people, what is the obsession that a theorist has over a blackboard? Like, why not whiteboard or something like that? You even wrote explicitly about whiteboards there. So, could you talk about that? Why does a theorist like love Blackboard?
that's an interesting question. I don't think anyone has asked me that before. But um, I don't know. It's maybe just some sentimental attachment for I haven't deeply analyzed it, but it is also there's a certain tactile feeling of working with a chalk and feeling the chalk dust on your fingers and eventually on your clothes and your this thing, and that when you write it, I think there's a sense of writing it's closer to when you write with pen on paper. I think there's a kind of a certain friction of the writing, which I think you like. It's good in some ways, I think, but I don't know the whiteboards. Firstly, the I don't like these markers, which are kind of very thick and very kind of and then it's very difficult to erase them, and they kind of the whiteboards very quickly become very ugly looking. I mean, full of like splotches of the marker paint, which you can't really get rid of. It looks very aesthetically also. I find it very unappealing aesthetically, I think. And blackboards, on the other hand, people who really write with a good handwriting on blackboards, it's always a pleasure sometimes to read that. And yeah, but in the end, this just a subjective thing. I don't know how many people you have polled on this, but I don't know. I'm curious. I think a lot of people like blackboards, and certainly at ICTS, everyone is very much into blackboards.
Yeah, but like I think after seeing the series Big Bang Theory, people there use. I think I assume that you would have watched that series, like at least a couple of glimpses. Like people there
Uh,
use whiteboards.
Yeah, I think no, throughout the world, I think it's whiteboards have taken over. I sometimes like to joke that maybe in the future there will be some more smart boards or something like that, which will be very much. I've seen some that technology, which is a little more like a touch screen, like on your iPad or something like that, which is not so bad, perhaps, I think. And I find whiteboards a bit like, in music, there used to be, at least in my generation, when I grew up, there were record players and these LP records, and then there were cassette players, which had these small cassettes, and then there were later the compact discs, the CDs. Uh, so the cassettes, the music cassettes were, I would say, like a kind of the worst of them. It had like neither the subtlety of the records nor the fidelity of the compact discs. So it was just some messy technology in the middle. So I feel whiteboards are a bit like that. Hopefully they'll disappear.
Moving on to the next question. Your advisor David Gross won the Nobel Prize in 2004. After that era, do you think physics moved from deep theoretical revolutions towards an era dominated more by experimental confirmation and maybe technology-driven innovations?
Uh, so, of course, what David Gross got his Nobel Prize for was work he did in 1974. So it was recognized about 30 years later. Um, and that in the subject of particle physics was a very high point, which helped to kind of complete our understanding of the standard model of particle physics. And I think theoretically, at least in particle physics, that was one of the major points. Of course, later Higgs and others were recognized for their discovery of the Higgs mechanism and the Higgs boson, which was also a theoretical thing, but done in the 1960s. It was recognized with the Nobel Prize afterwards when the Higgs boson was discovered. So it's true that maybe in particle physics, many of the theoretical developments have not had any beyond the standard model, since there haven't been significant experimental confirmation beyond what was known. Standard model, I think we haven't had many Nobel Prizes in that area because Nobel Prizes are typically given for things which have been experimentally confirmed. But you've had people getting, like Penrose, getting the Nobel
Hmm.
Prize for black
Black
holes, and
holes.
some of the important results in black holes, which have been experimentally studied. So that's a very fundamental sort of idea. There are people like Parisi who have been um, honored with the Nobel Prize for their work in complex systems, theoretical. So Giorgio Parisi is a very broad physicist who has contributed in particle physics, in statistical mechanics, condensed matter physics, many areas actually, and it's quite very fundamental work, theoretical work, deep theoretical work, and he got the Nobel Prize maybe 6 years ago. So it's not that I think the era of theory is sort of not there. It's just that some of the other frontiers of theory, other than particle physics, are the ones that have been experimentally making more progress at this stage, and therefore Nobel Prizes have a special mandate, and so that recognizes that. But I must say, Nobel Prizes are just one prize given by one academy. It's by a set of this thing. I mean, they try to do a good job, but that is not should not be taken as the be all and end all of science. And I think there have been a lot of great, very important theoretical developments, which will gradually bear fruit, both theoretically and experimentally, and we have to see how that progresses. Condensed matter physics, there have been many interesting developments, and I think that there are also a couple of Nobel Prizes in theory were given for the fractional
Hmm.
quantum Hall effect and related things, ideas of topology in condensed matter physics. So these are very deep theoretical ideas, so which have been experimentally confirmed in those cases. So Duncan Haldane's work in the topological ideas in condensed matter physics has been very influential, and so yeah, so I would not take it in that sense.
Nice. So, how's the landscape of quantum gravity research currently? Is there been any recent breakthrough that has excited you?
Yeah, I think quantum gravity research, of course, is a long. I mean, it has had a long history and has gone through many evolution, a lot of evolution, and there have been many approaches to quantum gravity. I find amongst them string theory to be the most compelling. Though I must say that I should tell maybe as to your audience that I started off as a bit of a skeptic of string theory. I was My thesis was on quantum field theory and things related to the strong interactions and what I mentioned at the beginning about. But at that time, I never went very much into the string side, at least in my thesis, though I studied string theory then, and I had a certain skeptical. I approached it with a certain skepticism because I think it's important for scientists to be skeptical. And but over time, I realized as I studied the theory and worked on it, I found it personally very compelling and very promising, and especially from the slightly different angle that I mentioned, that I have been approaching it. And so it was quite remarkable when Juan Maldacena, a classmate of mine actually from graduate studies, made this discovery called the gauge string duality or ADS-CFT correspondence, which really showed how quantum gravity could be understood in terms of ideas in quantum field theory, I mean, in a holographic way. So this holography of quantum gravity was quite, I think, a very remarkable step. Of course, this was in 1998, so it's been a while since that, the original insights of Maldacena, but the subject has developed in multiple ways since then, and it still continues to drive the research in the subject, whether it's understanding the physics of black holes or gauge theories or very subtle aspects of gravity itself. Um, so, uh, so I find this connection very fascinating, and it has shed light on the kind of questions that I wanted to answer. And the recent developments that I find particularly exciting here is the growing role of quantum information in
Hmm.
understanding quantum gravity. It has played a big role the in the more detailed understanding of black hole evaporation. And maybe in your podcast with Subrat, you might have touched upon some of those aspects. But it has also given a kind of a picture of how maybe ideas of quantum entanglement are really being encoded in geometry, in the geometry of space and time. The quantum entanglement of the gauge theories describe in a certain limit the geometry that emerges holographically from the gauge theory. So this relationship between quantum information and entanglement ideas and geometry, the geometry of space and time that's described by Einstein's equations or generalizations as in string theory. I think this is to me a very fascinating topic, which I think we are only probing the tip of that iceberg. And it is something which has been gradually, I think, coming more and more to the forefront. And and in the last 5 years or so, I think it has really gathered a lot of momentum. So I foresee that this area will be very fruitful in uh, in the coming decade or so. It will certainly yield a lot of interesting new insights into both quantum information on one side as well as on gravity and geometry on the other side.
I see, Dr. Rajesh. I also wanted to touch a little bit on the AI bubble and talk about AI that's been happening all around. So, how is AI currently changing the landscape of theoretical physics? That would be my first part for the question. Once you answer that, I'll go to the second part.
Yeah, it's people are definitely all, I think, testing it and trying to see how useful it can be, what it can do. I think people are trying to push it to its current limits, but the models are also getting updated by the month, so the pace is very rapid. I know that quite a few researchers have been talking about how it has really enabled people to do certain kinds of research with with a lot of prompting with the AI models. In a sense, the way you would work with a graduate student or a postdoc,
Hmm.
in a
Right.
way, something like that. But with the AI models, you can kind of accelerate that process, and that has been, I think, quite powerful. And I think some people have written about their experience doing that, how a project which is maybe would have taken 6 months, they could do it in like a few weeks or something like that. But what I wanted to just emphasize as a general point about the status as of now that I see is that people have made some AI aided kind of uh,
Hmm.
some works. Uh, these are probably not some. mind-blowing new works. They are things that would have been nice contributions if they were written by graduate students, etc., original, but not particularly path-breaking, in a sense, a little deterministic. So that's one aspect. I mean, you kind of knew that there was a solution and you worked through that solution. And the second aspect is that it's the it was also something that was very human aided. There was a lot of, I think, uh, back and forth in all this between the humans and the AI. It was not like the AI was spontaneously generating things or and doing things on its own. So I think it's still therefore at a very rudimentary level in terms of aiding physics research. I mean, even theoretical physics research, uh, and uh, and I must say, even the theoretical physics of the kind that many of us do, with formal theory, is still quite a bit removed from the kind of mathematical research that one hears a lot about AI proving some certain results or showing some problems that might not have been tackled before solving them. Yeah, this is the research in physics takes is of a slightly different nature, which is why I think it has the progress of AI has been a little bit different. I must also say that there's lot of experimental areas that people use the AI a lot because it's very helpful given when you have lots of data to be able to analyze it and do things. So that's a separate kind of using AI as a tool, very that's likely to be very powerful. And I think AI can automate a lot of things there that I think speed up things there in both um, analyzing as well as sort of filtering out some of the noise. So that's the broad situation. And so I personally, I think just in the last couple of weeks, actually, I've started playing around a little with with some of my colleagues and students, postdocs, about a concrete problem. I mean, it's an interesting specific problem. We don't yet know how it will, whether we'll be able to make complete headway in that, but it's a good problem which it's very difficult to attack very directly by pen and paper. You need to sort of
Hmm.
spot some patterns when some parameters become large, and so you have to do a lot of experiments in some sense with it. I've been using Codex and ChatGPT, and it has been very, I must say, uh, quite fun, quite a lot of fun to play with it. And it's like it's having someone who is quite powerful, be able to, you can explain, and I mean, it's like talking to a colleague. You can explain things, and it responds to it in a very coherent way and does the things. And so far, it hasn't done anything that has blown my mind away, and but it certainly, I mean, in terms of originality, but in terms of power and technique, it is certainly, I can see that it's very powerful and technically very strong. So if I have to get it to do many things, it's going to do things quite well, very fast. So it's very, that way, it's a great tool to have at this stage. I'll have to see how, as I progress on this project, whether I can see any genuinely new ideas coming out. But at this stage, it's been more like a tool.
It's amazing, Dr. Rajesh. Moving on, when the 2024 Nobel Prize in Physics was given to the discovery of foundational machine learning and neural networks, many of the physics people in the physics community were actually frustrated about that. They were not very skeptical about that. But after 2 years, do you think that award is actually justified? What has the opinion of the physics community changed to an extent, or what are their views still about it?
Uh, I am not sure. I've kept track of how people have views have evolved on that, but yes, I'm aware that people were a bit skeptical initially. But on the other hand, someone like Hopfield was very much a physicist and was inspired by ideas from statistical mechanics and to some smaller extent Hinton as well. So, uh, like my advisor likes to say, uh, physics is whatever physicists do. So in some sense, you expand the definition of physics as you go along. Physicists study many sort of systems, and these can be viewed as a certain complex system. After all, physicists are now studying biology and many aspects of life. So it may not be so unnatural to think of physicists studying complex systems that are able to at least capture some aspects of the brain or neurons or neural networks as they're called.
It's amazing. And I wanted to ask you about this. After becoming the director of ICTS, how has your lifestyle significantly changed? Like, how is the balance between that from being in an administrative role to that of being a researcher?
Yeah, I mean, it certainly has required some rebalancing, and but I do not see myself in a sense as an in an administrative role. I see myself either in some ways it's more like it's like part of a service that you're doing to the community to help to shape something which is larger. An institution is much larger than the individuals, and you're helping to shape that, and in some ways you're doing it as a contribution to the community. And I think even as scientists we all contribute in many ways to the community, starting from, of course, training students, teaching, but also then once again creating institutions, creating sort of refereeing works, organizing meetings. There's a lot of things that you do to around your research as well, which are important to keep the research system healthy and vital and creative. And so I see this as a part of my contribution to doing that. And so I try not to spend too much time on some nitty-gritties of administration. And there are competent administrative staff who take care of many things. But I try to look at the bigger picture and try to shape ICTS in directions that I think are academically fruitful, very lead to a sort of a unique environment where the researchers can do their best or do more than their best and do even better than they think they could do. So that would be my ideal of an institution. And you want to be able to create that. And it's not just about getting the wheels and the gears moving and the machinery of the thing. Yes, the machinery has to run, and you have to just make sure there are people who are helping to run that, but the machinery is not the goal or the aim. It is to sort of create a certain intangible atmosphere where creative work can happen. So that's what I see more as my role. But it does take time, and it has led to my rebalancing some things. I used to teach in HRI. I used to teach graduate courses and everything, which now I haven't. I realized that it would be impossible for me to do justice to my role and to my research and then teach. So I've had to step back from some of those teaching and other roles. I also take fewer students than I used to, though I still have PhD students and some summer some project students and so on. But the numbers have reduced, and so my ability to make commitments in those aspects of service, so to say, has reduced, and I've sort of shifted some of that to this. But yeah, it's a rebalancing, but I think it's worthwhile if one can make an impact.
So are you fine with this shift? Like you have said that you are focusing a little bit less on research and like more on these things. So which would have be very contradictory to what you did in the earlier stages at HRI. So how do you see the shift? Are you liking the shift?
As I said, I think I am still I've had to rebalance something, but I mean, even at HRI, I was involved in many aspects of, as I said, around research. There are so many things like students,
Hmm.
and then even there keeping the institute going with some and contributing to the institute. You did many things. You organized meetings. You did several things like that. So I think it's just a slight rebalancing. I'm still spending a lot of time on my research, and I think many of the ideas that I've had in started having from the HRI times, I think have started coming together in the last decade or so at ICTS. So in some ways, I think it's not so much also always about time. It's also about the kind of, I mean, sometimes things fall into place, but it's not just about the time that you spend. Time is important, but if your mind is in a better place, in some ways, I think so. If you get a lot of satisfaction from something, that I think automatically has a positive effect on your research also. So I think these things are not can't be separated like that. They're kind of all interwoven inside your mind. And so all I can say is that I don't think I've made much of a sacrifice to my research in these things. I think I'm happy with the balance I've struck.
That's nice. So moving on, this question is from one of our audiences. There's a perception among students that once scientists become senior faculty members, they gradually move away from hands-on research and become more like principal investigators, guiding students and postdocs. How true is that?
So, in some ways, in a way, I, as I said a little while ago, I have now actually fewer students and postdocs than I had before, and I have collaborators, and with them, I've been collaborating for actually a long time with some of them, and that has been great. I think it has helped, but I think at least in my case. I still try to be very hands-on, and in fact, just this weekend, I was spending most of the weekend on some calculations and doing something which then I could then work with ChatGPT on. So yeah, it gives me still a lot of pleasure being hands-on doing these calculations and having some nice little ideas, and that's what is really what keeps the spark alive. So I think I again, at least in my experience, I still try to be fairly hands-on, and but it's good to have very good collaborators who are strong, and then and they take things ahead quite a bit too. So that's also very helpful. Yeah. So it's true, but I think it's important still to be fairly hands-on with research.
So we are almost nearing to the end of the podcast. I have a last couple of questions. So if you could go
Yeah.
back in time and fix something from your past, what would it be and why?
Very few things, at least physics-wise. I mean, I think I Maybe during my graduate studies and my even for that matter, even in my undergraduate days, I spent a lot of time on several other things, which uh, I mean, I think I made a lot of good friendships and many other things, but I think I could have probably spent a lot more time. I used to wish I could work through the full Landau and Lifshitz theoretical physics series, which was one of my dreams, which I couldn't manage to do yet, but I'm still hoping that I can do it later at some point. So yeah, so I think even so during my undergraduate or graduate days, which would have been the time to do something like that, I think I didn't probably manage my time and the way I did things so that I couldn't end up doing something like that. Yeah, but though, it's not something I think a very significant thing. It's not necessary to. It was just a kind of um, a small fantasy to be able to master those because those books are beautiful. They are very beautifully written, and I've read several parts of several of the volumes, but so they are very attractive, even though maybe some of it is a bit outdated or some of it is a bit not quite current. But yeah, it's always very nice to see some new um, books on physics which cover many things. So I don't know, the physicists in this audience might like to look at David Tong's new
Oh, okay.
series of lectures and books, which I think is a wonderful place to learn. And if I were a student now, I would definitely work through those volumes. Uh, but of course, those books weren't there when I was a student.
Yeah, we had David Tonks as a reference in one of our last courses, mechanics.
Okay, yeah,
Yeah.
great. Yeah.
And the last question is, what is one final advice you would like to give to the younger students who are willing to pursue science as a career?
It's a great career. It's a lifelong gives you a sense of lifelong purpose, and it's very fulfilling. It's requires a lot of stamina, so you shouldn't have a very rosy picture of it, a rose-tinted picture of it. It requires a lot of stamina, a lot of staying power, and you have to be able to overcome sort of disappointments, failures, and other things. But but I think the process of continuously learning and the kind of neuroplastic changes that it creates in your brain is, I think, is a worthwhile thing to have throughout life, because then you're continually evolving, continually growing. So keep with that.
So thank you, Dr. Gopakumar. We are done with the questions. I thank you again for taking time to join us. I hope you enjoyed the questions.
Very much. Thanks for asking some very nice questions, and all the best to your viewers and people who are fascinated by science and physics.